notice when your, was that your height? When your height is 1, your base was 49. Which means that this height is
What happened with it?
1.
Okay.
And then this length is, so 1 plus 49 is 50. And if that's 50, we have a total of what? 100. So notice that adds up to 50, that adds up to 50, that adds up 50, because the perimeter, the whole distance around is going to be 100, right? But did we make it? Right, that
How
here
did
right
you
there.
get?
But come on, we should already have this in our calculator. Literally, you have it right there.
I know what to put that.
So what's the biggest area? Oh, come on, we should have finished it. We should be done. So you have those equations, right? Well, can the height
Cause I had
get
started.
bigger? Well, so let me point this out.
Wait a minute.
So you should have typed the formula in here, but look, I want to point out, the height starts at what? 0, and the base starts at 50. So what could the base get down to? What's the lowest that the base could be? And then the height we get up to, right? So go down. But remember, you should have written a formula for even the height. How do you get each of these values for the height? No. 0, 1, 2. So I could have just hit equals this previous cell.
Okay.
Plus 1. So how you do that? You remember how to do that? Right? So I want to add 1 to 0. So I hit equals. I click on that cell. And I add 1. Then hit enter. Now remember, because I did a formula, I can click on that cell, go to the bottom right hand corner, get that plus, and drag it on there. So keep it going. I don't know if I'm there yet, let's check. You said 50, right? Alright, I got 28. And notice because you wrote formulas here, if you're continuing it down automatically, so you don't have to draw that by hand. That's the beauty of developing this formula. Okay, you go further, you said get down, get to what number?
Justified, that's how you know that gives you things.
Okay, I got 38.
No.
Look at stop.
49. That was too much. Now, what I will probably do, not probably, I was gonna do it. See how I've got these rows highlighted? Now I can hit delete. That's fine. Ooh.
This whole column equals whatever this times this is. Automatically do it. So after the.
So you said, oh, number 1,
Okay, let's
do it.
There's another way to do this.
1-8.
I know it is.
Y'all work with each other. Alright. So look at your tables while I go check on the other groups. Alright? And figure out what the best area, what are the dimensions of the best area, and justify using that table. Think about other representations we could then use.
Is there any way you can like, we're gonna type all over that?
Yeah.
That way?
Uh-huh.
It's going down like here.
Nope.
Yeah, what's up?
So supposed to.
What are you talking about? The area? Look here. So remember.
No, okay, so that
You
area
hit
one,
equals
so
and you
this
clicked on a cell and you added 1.
column
So let's hit equals.
times this. So I can actually put a.
And I want to take this number,
Equal sign here is like a
and then I want to multiply
I can
it
do it here and it'll.
by this number. And because I use those cells, I can drag and drop them all the way through.
And so our area is equal to what? Times what?
See how it multiplies?
Okay, so that's all you have to type in. So
Taking that number, so click on the
times.
cell with 4, okay? Then you're multiplying that by that number.
And then get, those are all the areas, so it multiplied the first 2 to give you that 35.
Yo, I gotta go check on other groups, I got this other class, what's up?
What did you say you did wrong?
So, how did you get that 400? Multiply 40 by 10? So literally, write a formula, equals at 40
So you need to,
times, that's it.
Alright.
And because you use those
Okay,
cells,
so
when you hit enter,
this,
Equals?
cell,
I'll send
it
it.
doesn't.
Five, or is
That
that other than five?
all
the way through.
down.
Alright, and then go.
Yeah, sure you can.
Do it in that,
We'll meet
in
you,
that
because it
third
looks
box.
like I wasn't able to easily show everybody, show another, so
So-
we'll talk with each other, make sure you know how to do it.
The reason you have to do it there is because.
How's it going over here?
You tap the last box, you can.
It's not based on the whole brand.
So you write formulas or you type it all out?
In that first box.
You write the formulas?
So the equals,
You know how to do the formulas?
click the cell above.
Were you able to do the formula for this?
Oh, cool.
So what you're trying to do, you take C1, right, you're trying to multiply this number, right?
Five?
Yes.
Alright, so you're gonna take that C1 and add to it, you don't know what that rate changes. But to get the area,
And then it's gonna say that until you fill up all the rows.
you're trying to take the base,
You know how to drag
multiply it by,
highlight this.
because I used those cells, I can now drag and drop. That'll
But that's the base though.
label your variables, okay? And then analyze your table to figure out what's the best option.
Do you have all yours?
What's up?
Click on the box.
I know they ask you like for the whole equation.
Okay, so
You know how to do it?
Like, it doesn't.
here's, every time we're dealing with a table, you want to label your variables at the top.
Have you all even remembered how to do the formulas for the base and the height?
So do base height, and we can make an area to multiply.
Yep.
Keep on going.
Do what?
Okay.
So just, so this very top, where on the left side, this is where you put the variable names.
It's like no.
And then where the
type of
equal
number,
sign
like,
is, we can put formulas
Don't you
there,
get
but
named
we're not gonna do that yet. Go ahead and label
So
it.
is this your base or your height?
Y'all getting it now?
Okay. So I'm typing height.
Everybody can
Like,
take
okay. Oh.
So it's literally height. This is base.
Yeah.
And then this is area. Now, what I want to point out is, y'all can do this by hand. So Allie, right here, so after you, just because you can put these labels in later. Look, what's happening to the height every time? So I'm gonna come down to the next blank cell, and to do a formula, let's simply do height first. So I hit equals, and I want to hit the bar for it, because I'm taking what to that number.
First column is your base, second column is your height, and then based on heights gives you the
It's
area.
not super but because I use that formula,
Where's I said?
right, so it's all right here.
So whenever, I'm gonna start over.
Does anyone know what the height can get up to?
Whenever you have all these lines,
So,
you're trying to
So if you
multiply
do
something this
area.
way.
It started at 50, didn't it? So let's get the height up.
It only does it.
We'll point out after 50 is more because I started at 0. So now when I look at the base, what's happening to the base?
And it goes down each time, about two.
So just delete all
Look, I put one, I put it here. Try to figure out a formula, you can write it, but Allie, yes, you can go to your restroom.
I'll kind of do this.
Right. I thought it was.
You messed up.
I thought it was
Okay,
1
hold on, I wanna point this out.
She did.
These are just like computers, there's an undo operation that will undo whatever you accidentally did. So hit Control Z.
Because you're supposed to go like this. You're supposed to do it like this. That's how we got the whole inside.
That's what it
That's
is,
why he
right?
said it was height based.
So you're trying to make this into a formula.
I'm gonna rename your variable,
So-
because what happened is when you put base and height in as a variable, it like locks it.
So-
So now I'm gonna create a new variable. I'm
Remember, I'm
gonna
trying to take this number and what am I doing?
That's why I said. That's right.
So equals, I have to click on that cell. I'm taking that 0 right there,
okay,
right?
alright.
And see how it's highlighting that cell, and
Your-
I'm just
do you have your
adding
table
1.
done?
And because I created a formula, when I drag that down, notice how it's referring to A1, the one before it. But look right here. That one's referring to A2, the one just before it. So it keeps adding 1 to the cell just before it.
Okay, so where do you see that on the table?
I'll watch it.
Right, you get it. Because it's like you're going down.
Okay, so what are the dimensions
Well,
there?
I get pregnant now.
Okay, so what is that?
Just do 49.
Does that make sense?
I thought you were trying to
So now it's-
So now I just put.
And then,
I will point out, you wanna go, you want this to go all the way to 50, not just the row 50.
Why get so quiet?
So, use that to justify number 2.
So after you made
If you finish that, I want you to make a graph out of this data as
So,
well,
okay.
and see what you see there.
After you make the table, we'll be fine.
Have you figured out what the best dimensions are?
We have.
What is it? Okay, but you don't have that, so you need to make sure you get your table in there. You need your, you said 25 by 25, I don't see that on yours.
Oh, yeah, I kept going.
Yeah, we need to keep this video down.
what y'all got?
Right? So you need to take this and you can drag and drop it. Well, you haven't done for me there. Or there. Remember, you want,
When it gets to 26.
so you did a formula here to multiply the base and the height, but remember, this base can keep going. So what we want to do is hit equals, and I'm going to click on this number, because what's happening to the base every single time? So I'm going to add 1 to that.
Okay, just like that.
Now,
I'm
drag,
saying,
drop
just
that, and what did you say the base could go to?
50.
50. He said the best dimensions were 25 by 25. Y'all, I need you to turn off your phones. If you know that's yours, please just go turn it off now. Alright? So do the same thing with height, and then make sure you drag your area all the way through as well. Nope, stop doing it by hand.
I'm not, what's doing the driving thing?
Click on those numbers.
So is it?
Okay, there you go.
So I was dragging it and then it went this way and kept going.
So then hold it there, and release, and then drag down. There you go. Cool. So justify it. Use that table, maybe put some points on there. And then if you finish with the table, boys are a whole class discussion, put a, try making it bread.
So now, in our
What's going on?
height 3.
Have we figured, sorry, you're making life way harder than that. I love it, but I was gonna say, you don't have to do that table by hand. Now, it's easier because you already have it in your calculator. What's a number we could have gone by to make our table by hand easier?
I'm gonna do,
Like,
no.
couldn't you go from like 0
Because I was saying our
to,
last
instead
one,
of
so I
1,
need to- I'm gonna
at
call
least by
this-
hand,
Yeah.
0 to maybe 5? And then 5 to 10, and then 10 to 15, does that make sense? That's just to make your life easier, right? Yes, do the table in the calculator by ones, because like, that's a bit easy, but I wouldn't do it by hand. That's a lot of points. Now, have y'all figured out the best dimensions yet?
Do what?
I just said more height and base.
Oh, no.
Say that one more time?
Right, you see how the numbers
Why are
going
you
down?
gay?
Like, go down.
Hey,
Okay,
no, we don't do that
So
here.
in this
That's
column,
being disrespectful and putting people down for no reason.
It's not what he said, it's what he did.
It doesn't matter. You're using the term gay as an insult, we don't do that in this class. So, what was your question or point?
Right there, his numbers,
It's going down.
Well, but I will point out, the base is going down, but what's happening to the height? It's going up. So you need to look at the area, that's what we care about, right?
why does it go
So,
back down?
notice how the area is continuing to increase in your table.
Right, so it's really the same.
Wait, did y'all do all this by hand? Oh, ladies, no, look, we have a table in the calculator, right? Can't you, did y'all write formulas in here so that you don't have to do it by hand?
Okay, so
Because I don't see a formula right here.
formula to apply to the full row.
Okay, so you went pretty far. But notice you're doing all that by hand, right? But also, look at your, this is your base? The base. So, one, label your variables. The second one would be your height, and your third would be your area.
Well, somebody did.
Hey, quick question, or quick point I want to make here. At this point, you should all at least have one representation. We're going to get started in 8 minutes. That's it. I need you to answer number 2 quickly, and then move on to number 3 and follow the directions for number 3 on the back of the page. Because we're not just trying to find the biggest area, we're trying to discover what type of function. Quadratics. Which means we need to investigate our tables and our graphs and our equations. We clear? Thanks for at least one person responding. Let's get to work. There we go.
So whenever you want to put
Look right here. Remember, the whole thing is we want to
No, you
formula.
have, like, something
Now,
in one column,
when the base was 0, the height was 50. But when the base was 1, the height was 49. Oh yeah, you started it out right. But what's happening to this height here?
equal to
The height?
base.
Oh, I flipped it from what you had. It's decreasing by how much?
Which I gave it was like
1. So like here,
it sets it
so
so
to
like
do a
that,
formula, I'm going to hit the equals button.
change those.
And then I'm going to click on this previous cell.
Now that I-
Because what am I doing to that previous number?
So we could do.
This one. And this one I'm adding 1, I am subtracting 1. So minus.
So do we have to keep in mind that it's a
You
regular?
hit enter. And you see how it gave me 46 because it subtracted 1.
Oh, the.
Once you create that formula, if you put the cursor right there in the bottom right hand corner, you can hold here
Okay, so
and you
I
can
remember
drag
I
it
talked
down.
with you guys yesterday, but so that's.
And you can keep dragging it so you don't have to do it by hand.
Well, squares.
Now in this column over here, what's happening?
Rectangles
It's-
cannot be squares.
So you would do a similar thing with adding 1. And you go check on other groups, but I do want to point this out. How are we getting this area here? Those two numbers, right? So again, I can do a formula. Equals.
So basically.
Take
you're saying
this number,
is
0.
to be
Gosh,
a
I must have hit something wrong.
rectangle, you have opposite sides.
Oh, it's supposed to be on the right hand side. Oh. Here, it needs to be there. And then I can take that 0. Notice how it uses the cell name now? And then I'm going to put times. So I can click back inside of here. Times. And I'm going to click on this cell and hit enter. And it gives me that number. So now, again, I can drag and drop that formula.
Yeah, because the side, or because the, that what you mean, the
Yeah, so
side
they're all
goes
over.
longer?
So create your formulas and drag and drop them all the way through instead of having to do it by hand. That will save you
Square, this
significant
will
amount
have
of time.
opposite
Does
sides.
that make sense? Okay. So keep that going. Work with each other to get that right.
Why this can also be a rectangle. A rectangle.
Alright, how'd it go with sub
The
down
only thing I said that you're 25.
What are you doing?
Does that make sense?
So what are you trying to do here? Well, you already have height
Well,
base
is that
area.
what do you mean?
That's good. Right? Now, so right, so what you need to do is you need to type, there's 2 ways to do it. Right now, what you want to do is take that number and add 1 to it. So you would hit equals, and you would click on the previous number, so it's create a reference in that cell, and you're adding 1. Now, you can click on the cell.
I was just like, other side.
So you have to go to that right
Those all work.
Sometimes they set it, but you need that symbol, but now when you click on it, you can drag that. And you just go to wherever the last one was and keep dragging it down.
That's not a store or something.
I mean, like, I didn't just like,
$12 an hour. Books.
Okay, but say you're both on it,
Hey, don't do that.
so can't I just equals, click on that? That, because I use this. Can I drag and drop that? Right? So instead of doing how are you getting
That's a quadratic function.
now, because you use the cell, it'll reference the cell. And you can drag it.
ain't see walk up the bed.
Should I get my
Okay, so when we did exponential,
Yes, sir.
25. All of it is 25.
Yeah, but you should already have a table on your calculator, right? I wouldn't go by ones, but maybe you can do the fives on there to just reference, but you can also just analyze it. Because I want you to notice, like, the big thing for us right now is we need to analyze that table. Like, have y'all figured out what the best dimensions are? Okay. That was just to get us started on learning about what type of function.
You be making it seem like you just.
Starts with a cube. Thank you. Alright, so we're trying to learn about quadratic functions. So I need you to look at the table and figure out what is happening in that table. That'll also help you justify why the biggest area is, what's the biggest area? 25 by 25 for an area of 625, right? So why is that the biggest area? Sure, get those fives down there, but let's move more quickly, okay?
or you could say.
How's it going? Order number 3? We're analyzing that table. What do y'all see happening in that table? So if there's no pattern within the table itself, what's the pattern? No, just look at the area. So remember when we looked at linear functions and exponential functions, we just looked at the output, didn't we? And with the output, there was, for linear, it's constantly adding by the same amount, right? And for an exponential, it's constantly multiplying by the same amount. There is a pattern here. It may be harder to find, but there is a pattern. First off, what do you see just in general? Right now, those numbers are what? Do they always increase though? What do they eventually start to do? That's a pattern, isn't it? Have we ever seen a function that does that? So should we note that? Okay, those are things to think about, right? That's a detail to first talk about because that's going to help us explain why 25 by 25 is the best dimensions. Right? But I might make a table just right around here, see if there's a pattern, because there is. So your job is to try to figure out what that pattern is.
Well, because division is the inverse of multiplication, right? Kind of how we said, so we have a.
But I feel like when you look at this, like you look at this.
Hey.
Thank you. Thank you. Okay. So I'm going to go over a couple of details. First things first, we already know that the best dimensions are what? 25 by 25 for an area of 625 what? Meters squared. Meters squared, right? So we want to keep that in mind. Now, here's the thing though. Is this just about finding the best area and the best dimensions?
No.
Nope. It's about doing what? Finding that rate of change for a quadratic function, right?
Yep.
What else about quadratics?
And the table.
And the tables and the graphs and the equations. So I need y'all to make sure you have a table already made. Now, I want to point something out really quickly. I think a lot of us went the formula route, which is totally fine. Some of us asked questions, but notice down here, right? We took the previous cell and we added 1 to it for my base, right? Actually, I do want to pause and remind you all of this. If you're going to work with data or tables or things like that, what's the very first thing you need to do? Say that one more time. Understand those variables. If you don't put your variables at the top, these are just numbers, they don't mean anything. Make sure you label those variables, base, height, and area. So, any questions about how to do a formula like this where we just repeatedly add 1? I think I worked with everyone on this, yeah? Okay? And so over here, the height for me, and by the way, could you have switched it around and done height of 0 and base of 50 to start? Yes, that's fine. Okay, over here, what's happening? 50, 49, 48, right? So we're subtracting 1 every time. And I want to pause and I want to point out, I did not do that over here. If you look at this cell, notice how it says equals 49, but I didn't type that 49 in. So how did the calculator get it for the way I approached it?
Oh, yeah, that's
You put an equation in.
I put an equation in. Notice that equation up at the top? I defined the variable, so what I did is I just typed in equals. If I take 50 and I subtract the base, does that give me this number every time? 50 minus 1 is 49, 50 minus 2 is 48. You see how that would work as well? Now I want to pause because I want to definitely say a great thing about Anthony on this. Anthony, you didn't see it quite this way. What did you notice was happening?
What you mean?
And what was the equation that you wrote within your group for the height or for the base or whatever it was?
I just put -1 times 1.
-1, not times 1, times, come on, it says it right there, -1 times height
Yeah.
plus 50.
Yeah.
Where is that coming from?
That's the formula.
Okay, I'm going to pause for a second. I want to let other people answer and explain more about what you mean by that. Where is Anthony getting that equation from? Does anyone recognize that equation?
Based on height.
Not based on height, huh?
Okay.
And the height is big.
Because our height was our variable, was it not? Okay? Because Anthony noticed a pattern that a lot of us weren't paying attention to, or we might have noticed it kind of, but we didn't think about it this way. But what's happening to the height every time?
-1.
So what was the slope?
-1.
Technically, do notice, right, it was +1 over here to give us our slope. So our slope was -1.
-1 over 1, but then you do -1 divided by 1.
It's -1, right? And then what was the y-intercept?
50.
Oh. So could that equation have worked? So should we always be on the lookout for our rates of change because it might tell us an equation we can write?
Yes, sir.
Okay. We want to notice that there's a very simple equation that we could write here that we could have filled out. Now I want to point this out. To drag and drop, you have to type that formula into the cell, right? Which is what y'all are used to, equals and then taking this and adding it down. But if you want to create a formula based on another variable, you have to type it up here. Notice how it has an equal sign over here? So if you want a formula that is based on another variable, you start up here. And so I think some of us came here and we said equals, and we did A1 times B1 because it was base times height, and that gave us our area. Anybody have an idea, another formula that I could just type in up here to do it all for me?
Equals height times base.
So how can I access those variables?
Bar.
Remember, right here, VAR on the calculator gives me my variables. And so you can do height times base or just base times height.
Wait, you got a calculator on the computer?
What do you think I've been doing this whole time?
What the world?
I will pause and I will point out, if y'all paid attention to the syllabus and the newsletter I sent out, I actually have free software of this TI-Nspire that if you bring in a laptop, I will download this software so you can have it at home.
See, but I thought it was just a screenshot or something, and you put it on your whatchamacallit.
Like to show us what it looked like.
Oh yes, that's what I thought it was.
That's the actual calculator.
That's crazy. I didn't even know that.
Yeah, so if you want this software at home, you have a laptop, you can bring it in, I'll download it for free. Okay? Now, I want to pause for a second. I want to point out, we should be able to very clearly see, and you want to go ahead and flip over your page right now, because there is a point for extra notes on the back. What representation are we looking at for quadratics?
A quadratic function.
Well, yes, it's a quadratic function, but what representation?
Oh,
Table. What did y'all, because we should have gotten to numbers 2 and 3, what did y'all notice about this table that is different than linear or exponential functions?
it goes like this.
Okay, but if you see a shape like that, that's not a table. Maybe on a, what representation can you see this? A graph, okay? But look at this table again. What do you see that's different?
It keep increasing, and the more down the height.
And then it go back down. It start heavy and then it gets light.
Oh, So it increases, but then it starts to decrease. Have we ever seen that before?
No.
So in a quadratic function, in a table, we can see that the function increases and decreases. Now I want to point out, I did not say the function increases and then decreases, because sometimes it increases and then decreases, and sometimes it
Increase again?
decreases and then increases.
What the world?
So, yes, a quadratic function can increase and then decrease, or it can decrease and then increase. Right? So it just has both increase and decrease at some point.
So
Okay?
can it increase, then decrease, then increase again? Can
If
it
it's
do
a
that?
cubic function, not if it's quadratic.
That's what quadratic means.
Infinitely many types of functions out there.
Ah.
Look. Well, we'll talk about the equation in a second, and when I point out the equation, I'll show you why there's infinitely many. But I want to pause for a second. I want to point out, I heard someone talk about that it was increasing quickly, and then it doesn't increase as quickly after that. So let's look at that more heavily. What's happening here to get started?
All times, it's quadratic.
No, to go from 0 to 49. Plus 49? Does anyone know what's happening to go from 49 to 46? Plus 47. Anyone know what's happening to go from 96 to 141?
45. Divide by 2, no, subtract by 2.
And then 141 to 144, 184?
43.
So what's happening?
It's decreasing by 2.
What's decreasing by 2?
Right side.
Notice the rate of change. Because notice the area is not, right? The area increases by 49, then it increases by 47, then it increases by 45. But the rate of change is decreasing by 2. Wait, so 49 minus 47, minus 2 is 47, minus 2 is 45, minus 2 is 43. Wait, what is this called?
Constant.
Not just constant, constant,
Constant rate of change.
not just constant. Constant additive rate of change?
No, subtraction.
Subtracting's the same as adding.
Yeah, that's not what you're looking for.
You have additive and you have multiplicative. Remember, if I subtract, if I do 7 minus 5, isn't that the same thing as 7 plus negative 5?
So,
I don't
you
know.
gonna do, you can divide and then multiply,
8 divided by 2 isn't the same thing as 8 times 1/2, the multiplicative inverse.
yeah.
Does anyone remember me talking about that earlier today? Maybe during the bell ring? Right? So, we need to notice that this is constant additive right here.
What is that called?
Hold on a second. I want to pause, and I want to ask y'all, what kind of function has a constant additive rate of change?
Linear.
Linear. So if this is constant additive, how would I describe this rate of change?
Quadratic linear.
A linear function.
Not a linear function. What would I call this rate of change? This is constant additive. No. This is constant additive. Okay. Let's pause again and let's go back. All right. What type of function has a constant additive rate of change? Linear, right? That's a linear